And hello, welcome back here now to another episode on learning about Node.js. So, yes, yesterday we made a quick recap of what is GraphQL, okay? And specifically looking at how can we implement this mutation, okay? And understand what mutations are. Because in any API, you are most likely to read and gather data. This is more likely the most common operations you'll do. And that's one of the reasons why GraphQL focus on doing query really well. But what happens when you need to change the state of the application, the data in your server? Well, for that, since in REST we have something called crew. This is not particular to RESTful architecture. In fact, this is an operation that you're going to perform to any database. Crew operations. You have create, read, update, and read. Now, so far in GraphQL with query, we can and we saw how can we read data and how easily it is, especially when you have deeply nested objects with queries. Is just easy as just type only the property that you need for that, right? Now with mutation, which is the way of how to perform in GraphQL, create, update, and delete operations. Okay, this is underneath the hood works much like the query, and the term itself means that it changes, it mutates the state of the application. So that is the definition of mutation. And then I look at how can we implement that. So particularly here, it all starts in GraphQL with your GraphQL file or with your types. And in there, you define is right below the query, which is one of the root level operations in any GraphQL server, is mandatory. Then you have mutations, which are optional. Sorry, and the subscription. Again, this is optional. Right now, I'm for the course focused on mutations and how can we define a mutation, the name of a mutation, and here we just, for the sake of the example, is implement two of them: add a new product and add a product review. Okay, we define is first our mutation, add a new product, and the proper argument that we need to pass to add a new product. In APIs, specifically when you create something, it is good practice that you always return is the type of that element you want to store. In our case, a product. So that is the return type. Okay. Again, remember that in GraphQL, it all starts with your type. In our case, we want to make a mutation to create a new product. We define that and the arguments, and then we go now is to the resolvers. So in the resolvers, we need to add our mutation because mutations, as I mentioned earlier, is another root type level of operations. So just like our query, we add mutations right below that, and it is a map or an object where it takes the name of the mutations and the resolver function. So okay, so what's come next? What is the body of the resolver? Because we want to make our resolver clean and thin. Yeah, I want to make our resolvers clean, thin, and small as possible. So we want uh, that the logic where we define is a function that will take care of how to add that uh, product in the data layer access. We just only call that function. So this uh, makes our model independent, whichever model we want to use, regardless of database, whatever database, or any other implementation. So yesterday, I took a little bit of time to know and to recap, to refresh this concept, such as cohesion, and coupling, right? So according to I need to be more specific. Cohesion meaning in software, okay? Cohesion computer science, exactly. That's the context. So yeah, so cohesion refers to the degree to which elements inside of a model belong together. Or in other words, it's the measure of the strength of relationship between the methods and data of a class with some unified purpose. Okay, so uh, how is the relationship between the methods and the data for that class with that unified purpose? Sorry, meaning is the less responsibility that a model has, the better. The more closely related, the most closely related, and the less responsibility that a model has, the better. When it comes to high or low coupling, or coupling is the dependency that that model have with others. With coupling here, okay, is the degree of interdependence between software models. I like it. Okay, I measure how closely connected two routines or models are. The strength of the relationship between models. So it is the degree of interdependence between software models. So coupling can be low, also loose and weak, or high and high and strong. Some types of coupling in order to of highest to low coupling are as follows. I just want to look at another definition of coupling. Okay, cohesion. Sorry. Um, Cohesion in software. Uh, mm, Cohesion in functional cohesion. Mm. And it is important to look at that concept because if someone comes to you and say, "Hey, what the hell? What do you know that? Where it came from?" Well, you are able to tell them your source. Mhm. Mm. Yeah, because everybody has their own definition of what is that. Mm, mm, what about looking at this? They're able to mention a source. Mm, mm, mm. What the? Uh, okay. Oh, no. Cohesion and coupling. Coupling. I don't think it's this, but it has a high. Okay. From the introduction of object-oriented programming, Delphi. Okay. Mhm. 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 So coupling describes the relationship between models, and cohesion describes the relationship within them. I like this definition. I like the definition. We're going to put this in bookmark. Yeah, Node.js school. So coupling describes the relationship between models, and cohesion describes the relationship within them. Okay? A reduction in interconnected between model or class is therefore achieved via reduction in coupling. But in any case, this what tell us is this important subtle definition. Okay, the degree of interdependence between software, or it describes the relationship between models, and cohesion, the relationship within them. Okay, so with that definition, okay, so to understand the reason why here in our mutation we're putting is we're calling is a function that will take care of all of our logic to create a new problem here, because we want to keep this resolver file clean, thin, and small as possible, and be independent whichever model we choose to use, whether it's an implementation details, a database, uh, or any other module, right? And that's the core thing here, okay? So these encapsulations allow us to do that. And this is one of the core concepts of software development. The ability to have to cop the ability to have models with high coupling and with high cohesion and low coupling. So because of that, then we define is this function where we're going to pass is the argument, just like a pipeline, and inside of that data access layer, the product of model, we define is the logic that will take care of handle that create the creation of a new product. And here we're going to pass this the new object here, and then we push our new product into that product list. Again, we're doing this because for the sake of the example, we rely on the built-in database or this built-in memory data. Okay, okay. Uh, and then we describe is our mutation here. So in our GraphQL, this behaves much like similar as the query, but if you remember with query there is no need to define is the keyword, but with mutation you need to define that and has the proper arguments that you're going to receive and indicate what are the property you want to return. That's one of the beauty of this. It solves the overfetching problem, so you don't necessarily, or the server doesn't necessarily return all the fields that are not relevant for the user in that particular case. Okay, you only ask for the data that you want, and also you solve the underfetching problem by querying multiple collection of values in a single entry point, making it making the wait load time keep at minimum as possible, and then you will get this. Okay, the data product here. So okay, sorry. So that was quite illustrative. That was quite illustrative to see what can we do and what is the GraphQL way of perform crew operation. Okay? Also, how can use Graph npm package like GraphQL tools to make our GraphQL scalable and maintainable by splitting its the two main components in any GraphQL server, schemas and resolvers, okay, and also understand the most two type operations that we can do, query and mutation. You can also do subscription, but this is something that go beyond the scope of this course. But it's important to understand and to know that you can do that. So once I know how to create a server from scratch, make our GraphQL server scalable, relying on npm package such as GraphQL tools, which underneath the hood Apollo use that, and see how you can modularize your GraphQL applications from the schema and the resolvers. See the relationship between the resolvers and the controller in a RESTful architecture, which is pretty good. See how you can define is query, how you can parameterize queries, uh, and set mutations and understand the mutation and how to implement a mutation, and see the important concept of high cohesion and low coupling. So high cohesion is the relationship within that model. Okay, high cohesion or cohesion describes the relationship within within them, right? That's what describes cohesion. The relationship within. Uh, sorry. the relationship within models. And coupling is the relationship between models. So one of them is the relationship between models, and the other is the relationship within them. Okay. So higher cohesion means that the relationship of the data and the methods are unified to a particular class is desired because it increases reliability, maintenance, and having a low coupling meaning that the relationship among other models are kept to a minimum uh, is also is a desired trait from software. No, okay, no, okay, okay, okay. Now, now I ask myself, how can I perform several mutations? Because with GraphQL we can perform several queries. Okay, we can ask for queries, so we can ask for data. We can ask for different type of data in one single query. With mutations, how can we do that? Okay, we're going to practice how to write mutations and how dive deep how mutations are executed and how to execute many mutations at once. This is the focus here. So let's do it. I think I'm going to need to raise over here. No, just want to sign in here. Alright, maybe need to identify that. But maybe it's my password. I'll be using it for this key password for that. Okay. Mm, Alright. Now let me sync with this. Alright. Good. Great. Okay. Jump to Node here. Let me go to GraphQL section here and with okay.
We've set up two aliases to differentiate toward. Let's take this opportunity to practice writing mutations. Then, towards the end of the video, we'll dive deep into how mutations are executed and how to execute many mutations all at once.
Okay, again.
Let's take this opportunity to practice writing mutations. Then, towards the end of the video, we'll dive deep into
Towards the end of the video. Okay. Towards. Towards. Uh, in future the direction along a course leading to in relation to okay at a point direction toward all English toward then toward okay
how mutate practice writing mutations. Then, towards the end of the video,
towards the end of the video. Uh-huh. Okay, so we're going to practice how to write mutations, and toward the end of the video,
We'll dive deep into how mutations are executed and how to execute many mutations all at once.
okay. So this is the two things that we're gonna see: how to write to get ourselves much more familiar with how to write mutations. Okay, and then toward the end of the video, see how mutations work and to see how mutations work and how to perform several mutations or many mutations at once.
Let's get to it.
Okay.
Based on the add new product mutation that we just created, see if you can implement a mutation to add a new product review to an existing product. This mutation can return back either the new review object alone or the entire product with its newly added review. Pause the video, give this a try, and then let's go over the solution.
Okay, so what you can do here is just creating is the mutation of add new product review. You're gonna pass this the ID for that product and the rating and the comment. So this is just to define is the mutation.
How did it go? Ready for the solution? We start with the mutation type, adding the name of our mutation. So let's be clear and say add new product review. And we already mostly decided how this mutation will look earlier in this section. We need to associate a new product review with an existing product. So we'll say that the review is associated with the product with some ID that we pass in as the first argument. And then our review must have a rating, which is an integer, as we see below right here. And we have an optional comment, which is a string. For the return value, let's just have our mutation return back the newly created review object. There we go. Now in our...
Okay, so let's go to look at the Visual Studio down here. Okay. Alright, it takes some time because it's loading the data from the WSL, Windows Subsystem Linux. And here we are. But to run this, we need to use this Node version and then run that. I'm not going to do that, right? Because I want us to define is a product review. Again, what I'm doing here is just expand the capability of this GraphQL server by adding is a new product review mutation, right? So here you tell this, well, you know what? This will be a type ID of the product to link that, and then the description, right? Which will mean is the grade is the review data. So in our case is rating as an integer is required, and a comment which is in the string, and from the return type we define is the review object. Okay. Then in our resolvers for the product, here we add under the mutation map a name of our mutation, add new product review. Okay. and the resolver function, which in our case we're going to use is the parent value, but the argument that comes from it. Again, we define is a we're going to define is a function in the data access layer that will take care of all of the proper logic to add a new product review. This is to make our resolvers small and thin as possible so we can make this independent uh, from any other models or implementation details or any or database, whatever database you want to use. So here we're going to pass is the argument from the ID, the argument rating, and the argument this one. Is counted. Exactly. So going back now to the data access layer, which in our case is which in our case is the model product model. Here I define is right below this function, the function add new product review, where it going to receive the product ID, the rating as an integer, and the comment. Okay. So we want now is to locate is the product first and then add that. So the easy way to do that using this array function is that here we're going to locate is the product. You say is product review, okay, or you can say is just the product like that. All right. What you're going to call is the product list. Find that by, you can say is because we already have the index, find index, okay. This will return is the number, but in our case we want is the element. Find, we need to pass is the predicate here to say, hey, this is the ID that we are receiving here, and we want is to now match the product dot ID with the same ID, right? But again, this is product for that, and this is what we want to match. Once we get is that product, now we're going to add the review as a list that comes here as review. We're going to define is that particular review is an object where we say, hey, this we have is the ID, not the rating, and the comment, okay? And this is what we're going to add in the product dot review dot push, because this is an array data structure with the new review. You can say here is new review. So we add this, no problem. And we're going to return is the new review. Just like that. So don't forget to export this new data layer function, the add new product review as a reference, okay? And then you save here is your function, but we need to define here is as an arrow function, okay? So let's see how they implement.
Growing products resolvers file, underneath our add new product mutation, we'll add a mutation field matching our schema. So add new product review. And again, we are ignoring the first argument, but making heavy use of the args, which include all of the data for our review. We're going to be calling some function in our products model that we'll call add new product review, passing in the ID of the product we're reviewing, the rating for that product, and optionally, a comment for our review. This model function will return back the review we just added so that our mutation can send it back to the user. Very similar to our original mutation. Now in products.model.js, we'll add our function to add new product review, which accepts the product ID, rating, and comment. And here things get a little bit more tricky. We first need to find the product that matches this ID so that we can add the review to the appropriate object.
But since we already have that function that we defined previously, okay, for example, in our product models, there's no need to do things like this. In fact, we can just call our function here, get product by ID, and you pass this the ID for it.
So we're going to use the find function on our products array to find the matching product that's being reviewed. In fact, we need exactly what our getProductById function is already doing. So we'll make use of this function inside of add new product review. We'll create a new constant for the matched product corresponding to the ID being passed into our mutation, and we'll set this matched product to getProductById using that argument, so ID. Now, if a matching product isn't found from the find function, the result will be undefined, which we should check for so we don't try to add a review to a product that doesn't exist. So we'll say if matched product, then we'll create a new product review constant with the data that was passed in to our resolver.
So this is to check. This is for validation. Here I'm assuming it's the best possible scenario, but you shouldn't do that, right? Or here they describe it as matched product. Matched product. If that exists, matched product, then is what you're gonna do all for that. And then you're gonna return is a new
This is going to have the rating
or new product review. Exactly. New product review, and you're going to return uses.
as well as the comment if it was set. Finally, we'll add this new review to our matched product. So we'll say matched product dot reviews.
Oh, exactly. Because in our case, we didn't add that. It's dot match product to a review for that.
Dot push, passing in new product review. We could check if reviews is not undefined or null, but we know that the reviews are always being set to the empty array for new products. So for our example here, we'll be a little bit less safe, but keep things nice and short. Finally, we'll return back that new product review if there was a matched product, and undefined if no review was added because no product matching that ID exists in our data model. We can't forget to export our new function right here at the bottom of our file, and we should be good to go. Our model, our resolver, and our schema are all in place, which means we can test some mutations. We'll make sure our server is running with the latest changes. Now in GraphQL, we can make as many mutations as we need, adding any new products that we want with any product reviews. Let's do 2 reviews as part of this mutation. We'll do one for the red shoe, and then I copied this over, and let's do one more for the orange jacket. Let's make the orange jacket review a 4-star review out of 5 with a comment that says, this jacket is fit.
Okay. You are performing several mutations. So add new product.
Very warm and very orange. All right, so we have 2 product reviews and 1 new product, all being wrapped up together as part of this single trip to our Node GraphQL server. But you may notice that GraphQL is underlining our add new product review mutation here and saying that these 2 similar mutations at the bottom of our screen here are conflicting with each other. Why is this? Well, think about the response that we'll get back in GraphQL, the response from our GraphQL server. We'll have 2 add new product review mutations, each getting a rating, but they're 2 different mutations. And they're going to be under the same add new product review data object in the response. There's a conflict. What we need to do.
Okay, so let's see. Let's add new product review. Come on, no. You're gonna pass this ID on. Here the definer is the red shoe and orange jacket. Red shoe. The rating as 5, and the comment.
We'll do one for the red shoe, a 4-star
Gray coding shoes. Okay. And the comment is gray coding or dogging coding shoes. And the similar, here the one is the rating for that. And the same here for this. And new product review from the red shoe. But here is different because here is the orange jacket. Orange jacket. If you ask for the ID, from review, because that doesn't exist. So it tells you fields add new product review counted because they have different arguments. They have different arguments. Use different alias on the fields to fetch both if this was intention.
Review out of 5 with a comment that says, this jacket is very warm and very orange.
So here the comment is, this jacket is very warm and very orange. Jesus. Okay. The lack of creativity, but it's okay.
All right, so we have 2 product reviews and 1 new product, all being wrapped up together as part of this single trip to our Node GraphQL server. But you may notice that GraphQL is underlining our add new product review mutation here and saying that these 2 similar mutations at the bottom of our screen here are conflicting with each other. Why is this? Well, think about the response that we'll get back in GraphQL, the response from our GraphQL server.
Yeah, the response here will be from rating But since we are doing that for different products,
We'll have two add new product review mutations, each getting a rating, but they're two different mutations.
so the different mutation you will get is the rating for all of these different mutations. So think about the data that we can going to get back from that.
And they're going to be under the same add new product review data object in the response. There's a conflict. What we need to do is add an alias to each of these conflicting mutations to differentiate
So
between
the
them.
conflict is because you're performing is two mutations, two different mutations. You are doing is two mutations with different arguments that think about the output that you're going to get from it. So there is a conflict for that.
The way we do this is by adding a name in front of the mutation. For the first one, let's call it shoe review, followed by a colon. And for the second one, let's call it jacket review. Just like that, we've set up two aliases to differentiate between our mutations. Let's see what happens. Very nice. We got a new product that originally had 0 reviews. This makes sense because GraphQL executes our mutations one by one in serial and not in parallel all at once. So first we add this new product, and only then do we add the reviews once the response to our add new product has already been set. So after add new product, the product review was added for our red shoe and then for our jacket. And we're getting back the ratings for both reviews. Great stuff. Now we can make a query to get all of our products, specifically getting the description and any
And the
reviews,
reviews.
including the rating and the comment of each review. After our mutations, let's see what comes back now. Beautiful. We're getting our red shoe with our 5-star review. We're getting back our blue jeans. And finally, the new product that we added, along with the review that was added separately after the jacket was already added. We now have the ability to create, read, or update data all with GraphQL's query language. All right, we're ready to move on to the next video. I'll see you there. There's a question. Very nice.
Show review and jacket review. Shoe review and jacket review. So this is our mutation. In the query we can perform. We get is shoe review and jacket review. So the mutation are performed one after in serial. One after another. So the mutations are performed in series. Alright. Okay, cool. So that's the whole
We got a
here.
new product separately after the jacket was already added. We now have good news about all of Apollo's extra features is that they have this excellent website. Welcome back. We've been building our server and feeling really good about our GraphQL. But someone comes along and asks if we know Apollo. And can we work on an Apollo GraphQL project? We pause for a second, but we remember that we're ready for this. All right, what's the first thing that we need to know? Well, what exactly is Apollo, and how does it relate to what we already know? Apollo is another GraphQL implementation, very much like Facebook's reference implementation that we've been using so far. However, Apollo is much, much, much larger with more features. It has all of these different libraries to make GraphQL queries and save GraphQL data in React on iOS, as well as Android. There's a server component, which is a replacement for Express GraphQL. It works very similarly, but adds some extra features if you need them. And there's a few more advanced tools that the Apollo team has built if you really want to commit to their platform that help you build Apollo projects as part of a much larger team. But the two main components of Apollo that you'll see in your development career are this Apollo server and the Apollo client, which is where we'll start because the client is where Apollo's benefits really shine. Apollo client is a set of front-end libraries that help make GraphQL queries and save GraphQL data in your front-end. Using Apollo is much more convenient than making post requests to your GraphQL endpoint on your server directly. It lets you query your GraphQL server with your front-end application much like you would through GraphQL. And it comes with added benefits like caching your queries, handling loading states and errors, and keeping your data synced with the server. It makes the data that you fetched available to your front-end components, whether you're using React or Angular on the web, iOS, or Android. It handles connecting your components with the data that comes back from a GraphQL query without having to hook things up manually. That's Apollo Client. What about Apollo Server? Apollo Server is its own package on GitHub, which allows you to create a GraphQL server in Node, very much like our Express GraphQL package. But Apollo Server can work with Express or Koa or pretty much any other popular Node framework. Even better, it helps you run and deploy your GraphQL code to serverless environments, like Amazon's Lambda service on AWS. And it includes functionality to help implement subscriptions in your server. Subscriptions are the third type of GraphQL operation. We had your normal read queries, we had mutations, and we have subscriptions, where subscriptions allow you to push updates from the server to subscribing clients, much like push notifications on your phone. Subscriptions are a very advanced GraphQL topic that's needed much more rarely than mutations and queries. Now, all of these things are possible with Express GraphQL, that package that we've been using so far. But Apollo Server wraps up all of this functionality into your GraphQL server and exposes it individually in a set of NPM packages. There's this page on the Apollo GraphQL website which explains how to choose the right package for you. We have the batteries included Apollo server package that includes just about everything, but then we can choose some different options. There's Apollo Server, but there's also Apollo Server Express, which allows you to use Apollo Server in an existing Express API. This is the most widely used version of Apollo Server. But we also have serverless specific packages, where we can run an Apollo server on AWS Lambda, or Google's offering, Google Cloud Functions. And there's plenty of other options for other Node.js frameworks, whether it's Koa, Happy, or Fastify. The good news about all of Apollo's extra features is that they have this excellent website right here. If I zoom out, we can see that it has this really, really excellent documentation on all the different features of Apollo, regardless of which aspect of it you're using. And the even better news is that when it comes to Node and the backend, Apollo will feel quite comfortable to us with our experience so far. The server-side component is very, very close to the GraphQL code that we've been building. So let's keep it going and see Apollo Server in action in the next video. See you there. Welcome back. In this video, we're going to write a fully functional Apollo server. The Apollo Express NPM package that we see in front of us is the most widely used way of using Apollo with Node. It allows us to combine Apollo with an existing Express server to take advantage of the best of both worlds. Now, here's a fun question. Can we convert our existing GraphQL server to Apollo Server Express without too much effort? You might be surprised. Let's dive in and see exactly what it takes. First things first, we're going to uninstall the Express GraphQL library, which we're going to be replacing with Apollo. So in our terminal, we'll do npm uninstall express-graphql. Now we need to replace that with our Apollo Server Express package. So I'll clear the terminal and npm install apollo-server-express. Our packages are now where they should be. We can go back into the code and remove our Express GraphQL middleware that allowed us to respond to GraphQL requests in an Express server using the GraphQL HTTP function. So we're going to remove that and replace it with an import of our Apollo Server Express library. This module exports something called the Apollo server, which is going to handle all of our incoming requests, whether they're for GraphQL or another Express middleware in our server. So how do we use this Apollo server anyway? Well, the convention with Apollo is to use a function that we'll define right here above make executable schema that we'll call start Apollo server. You'll see this in most Apollo projects. Just like every Express server, we're going to initialize our application, calling that Express function. We're also going to make use of our GraphQL tools make executable schema function, which is fully compatible with Express GraphQL and Apollo. So we'll move that into our start Apollo function. Let's remove some of this white space here. And we'll also remove this /GraphQL route with our old Express GraphQL middleware that we're no longer using. But if we got rid of the GraphQL endpoint, we need to replace it with something that Apollo provides for us. This is where our Apollo server comes in. We'll create a new Apollo server instance, which will take in some options. We'll see that in just a moment. And we'll assign this to a server constant. This Apollo server object contains all the middleware and logic to handle incoming GraphQL requests. What we're trying to achieve is to make our executable schema with our type definitions and our resolvers. We want this schema to define how our Apollo server responds to GraphQL requests. The way we do that is by passing in the schema object as an option to Apollo server. And Apollo server accepts the schema made by make executable schema from the GraphQL tools library. Apollo and GraphQL tools work so well together because GraphQL tools was originally written by one of the Apollo developers, which makes it much easier to transform projects that use GraphQL tools into Apollo projects if you want to. It's really powerful stuff that we're about to experience. So let's keep going. Because we were already using make executable schema, we can pass that directly into our Apollo server. And we can use this shorthand syntax to make things even cleaner. Now, one reason why we use this start Apollo server function, this is so that we can call await on server.start. This will tell Apollo to prepare to handle incoming GraphQL operations. With Apollo server ready, we can now call server.apply middleware, which connects Apollo's GraphQL middleware with our Express server. We have to tell the function which Express application to connect to by passing in the app object, and we can optionally choose a custom path to handle our GraphQL requests. By default, this is /GraphQL, but we can change this to anything we like. This apply middleware function is basically calling app.use on the middleware that is created inside of our Apollo server, and then mounting that on the path that we specify. It's just a convenience function for exactly that. Finally, we start listening for HTTP requests, whether they're GraphQL requests or other requests that will be handled by Express, by calling app.listen inside of our Apollo server function. So let's move that right underneath where we apply the middleware. And that's basically it. Of course, we have to call our start Apollo server function. So let's do that right below where it's defined. Will this work? Let's see Apollo server in action. In our terminal, we'll clear the console and npm start. The server seems to be running, So let's load our browser and see what we get under the /GraphQL endpoint. Apollo server is on port 3000 under /GraphQL, so let's load it. Hey, okay, wait a second. What's this? This isn't quite graphical. Let's see. We'll check this automatically redirect me to Studio and select Query Your Server. Let's see what happens. We're taken to this Apollo Sandbox tool. This is an Apollo front-end application that is much like Graphical, but is built specifically for Apollo. We can query our fresh Apollo server in this operations box exactly the same as when we used Express GraphQL. Notice that this Apollo Sandbox has pre-populated our query, which is showing us an added feature of GraphQL that we haven't yet discussed. We can name our queries and mutations by adding a name after the type of the operation and before the object, which contains the fields from the response that we're interested in. We could name this anything we like, say funny query, and we can execute it to get the response just like we would with Graphical. Notice we're getting the orders and listing our single order's date and listing all of the product IDs. Apollo Sandbox has even more features than Graphical. Notice that we're getting the HTTP status code, how long the request took, and even how large the response is in bytes. It's almost like a fully featured Postman specific for GraphQL. And just like Graphical, we can explore our documentation here on the left, listing all of the queries. And if we go back or click on the root, we can also see our mutations. To add a new product, we can click on one of these fields to list all possible arguments and fields in the response, using that as a reference when writing a mutation. For example, we can add a mutation, and if we give it a name, like funny mutation, we'll be able to select whether we want to send the mutation or the funny query to our server. Naming our operations lets us pick and choose which one to execute at any point in time. As an example, let's add a new product inside of our funny mutation here. We'll add new product, passing in an ID, which will make yellow jacket, a description, sunny jacket, and a price, which we'll say is $90.88. We'll pick from the result the description of our new product. Notice that now the execute button or the submit operation button here will execute only this mutation. We've added our sunny jacket. And now if we click on funny query and submit that, we're getting 3 products and all of our latest changes. Just a quick sample of what we can do with Apollo. See, that wasn't too large of an effort, was it? All the steps that we've taken to modularize our GraphQL server made it easy to migrate from Express GraphQL to Apollo server. We could now explore more Apollo-specific features and combine them with what we've already built. We could integrate with an Apollo frontend. We could add more specific database features or implement subscriptions. The possibilities are endless. Our GraphQL journey is just beginning, but we've done all of the hard work. Our GraphQL fundamentals are now in place. And that's what I'll leave you with. I'll see you in the next one. Bye-bye.
Interesting. Very, very interesting.
Hello again, and welcome to one of my favorite sections. We're going to be learning about something that is fundamental to the internet. We're going to be learning about sockets. Now, I know what you're thinking. I know what HTTP is. I know how to make requests. So what's all this sock business? And what do I even need this for? Well, bear with me here, and when we're done, you'll know more about sockets than most senior developers. And you'll be able to put this to use to make some really cool and unique web applications. All right, so as a starting point, say we have a chat application, like Discord or WhatsApp, and you're making requests to the server. Sometimes you're sending a message, which we now know is a post request, and sometimes you're getting the messages that everyone else has sent, which would be a GET, say to the messages collection. So sounds fine, there's nothing new here, but how do we know when somebody has sent us a message? How do we know when somebody's behind their computer typing away? Even if we know them really well, that's kind of impossible to predict, right? So how do we know when to make that request? It could be right after we send them a message and make that post request. Or it could be a couple hours later. Or heck, they might be really busy or maybe not that excited to get back to us. And maybe they respond in a few days. So when do we actually ask the server for new messages? The answer lies in sockets. But first, let's take a look at how we might approach this using what we already know.
Polling.
In our chat application, we saw this question of when to fetch data from the server, specifically for data that's not under our control, data that we didn't create. This data might have its own life cycle that's impossible to predict, like when somebody wants to chat with us and the messages that they send us. Often, we deal with situations like this, quite effectively actually, using an approach called polling. What this just means is that you make that GET request every so often. You just choose a period of time, and when that time is passed, you make that request again, in a loop essentially. So let's take a look at how this might look on the client side. We can start by defining the polling rate. So let's say 500 milliseconds. And then we can use setInterval to make our request to the API every so often. So we're going to make that fetch inside of our anonymous function here to an imaginary API, say https api.mychatapp.com. And we're going to be querying the messages collection. Now, this will default to a GET, and we want to make this request every 500 milliseconds. So that's why we defined our polling rate. And normally we would set the result of this GET request to some state in the application. So let's say messages. And let's just simplify and ignore for now that fetch returns a promise. So this would work. Each time you're fetching all the new messages that were sent to the server since your last GET request. Now, you might see a few issues with this approach. You might have a few questions like, how do I choose the right period of time? And is there even a right period of time? Doesn't it depend on how often the data is changing on the backend in our database? If you're asking these questions, you're getting it. With polling, often the best we can do is just barely good enough. With a 500 millisecond timer, we would be adding that 500 millisecond latency or delay to all updates in the application. This might be okay in a chat application, but what about the really interesting stuff, like self-driving cars or stock trading or games? Imagine a multiplayer Pong application. Remember that classic arcade game of virtual ping pong? 500 milliseconds of latency can mean the difference between hitting the ball and letting it pass right by you as you watch helplessly. Now, spoilers, we're actually going to build this multiplayer game and not the choppy version you see here. But coming back to our chat application for a moment, we may be fine with compromising. After all, 500 milliseconds isn't that long to wait for a hello, right? And even so, with 2 requests per second, you might be doing the math right now and thinking, doesn't that add up to a lot of requests over time?
Exactly.
That's 120 requests per minute, per user. We're going to need a bigger, more expensive server. Or will we? Sockets to the rescue. All right, so let's get into it.
Socket makes two-way bidirectional data cost efficient.
What is a socket? Well, it's really just a plain old English word. Let's take a look.
An opening or hole that forms a holder for something.
Socket is an opening or hollow that forms a holder for something. This is true of sockets on the web and in Node.js as well. The something here is just data. So a data socket is an opening in a computer system which you can connect to send and receive data. It's a holder for this connection on a network of computers. That's it. This communication of data is what the internet is based on. You'll see this term come up a lot in various different contexts. You might see internet protocol sockets. These are basically the building blocks of the internet. You might see datagram or UDP sockets, which are used where low latency is the most important factor. And you'll definitely see TCP sockets, where the most important thing to know is that they're connection-based. So you need to connect to one of these sockets before you can send data through them. And they're also reliable. So if you send a message, you know whether that message has been received or not. And you'll have WebSockets, which we'll talk about very soon. And even HTTP, which, while it behaves a little bit differently from sockets, is actually built on TCP sockets. We have HTTP connections, right? And if an HTTP request fails, we get an error response, right? And all of these are different types of network sockets. All of these types of sockets are all subtle variations on the same concept. Now, don't worry if you haven't heard all these terms before, or if this doesn't make complete sense yet. As you get more comfortable with sockets in Node, you'll quickly be able to pick up the meaning of sockets in other contexts as well. Don't worry, it'll all make sense. The most important thing for us as web developers and backend developers is this concept of WebSockets. The internet consists of billions and billions of basic internet or internet protocol sockets. Built on top of those, we have WebSockets. This is a JavaScript feature that allows two-way communication between a user's browser and a server. This is where the real power is. Let's start by looking at how WebSockets are different from our polling approach. Remember our chat application? We sent HTTP requests like POST and GET from the client to the server, both for getting the existing messages from the server and for posting new messages to the server. When using WebSockets, we still have a client and we still have a server. But the client, our chat application over here, can send the server messages whenever it chooses. And here's the different bit. The server can in turn send the client messages whenever it chooses. The communication is bidirectional. It can go from the client to the server in this direction and from the server to the client in the opposite direction. Sockets open a channel between the web browser and a web server that allows real-time communication and transfer of data between them. By keeping this channel over here, or this connection, open, sockets allow a two-way, ongoing conversation to happen. Let's see what this would mean in practice. So what would our chat application look like with WebSockets instead of HTTP requests? Remember, we send messages from both the client to the server and also from the server to the server's clients. When using sockets, we can send a message from the client to the server using this emit function. So we can emit a message that is saying hello.
Yeah,
we'll see a lot more of this emit function when we start looking at our...
I'm quite familiar to that. But what I want is to, I just want to look at what is their way of explaining that. What is their way of explaining things? So, that'll be all for this video. And then take care. Bye-bye.